Alright, so let's get started then. This is increasing and decreasing functions. How to tell if something is increasing or decreasing. Now basically put, as we move from left to right on a graph, if your value is getting larger, then you are increasing. If your value is getting smaller, then you are decreasing. That's the basic definition for increasing interval on a function or decreasing interval on a function. We're going to do a little investigation to see if we can determine that a little bit easier and without necessarily looking at a graph, because in this unit we want to use all these skills to actually help us graph. But first, let's look at a graph. So in this little investigation, here, this red graph here is the function x cubed minus 4x. If we take its derivative, we get 3x squared minus 4, and that's the blue function right there. So first, let's look at over which values is f at x increasing. Well, over here, it's definitely increasing, all the way up until about -1. And then it starts decreasing. So we can say x is less than -1. It's increasing on that interval. And then as we come down, we eventually reach another horizontal tangent here, and we start increasing again when x is greater than 1. So those are the points where we are increasing. Alright, then where are we decreasing? Well, we're decreasing from here to here. So from -1 to 1. So x will be between -1 and 1. Now if we look at that, let's look at the graph of the derivative when f at x is increasing. So right here, when this is increasing, all the way up to this point, -1, there's the derivative. Now it looks like the derivative is decreasing, but we'll talk about that in another lesson. But for now, you can see that it's always a positive value. It's above the x-axis. So f at x, or sorry, f prime at x is positive when f at x is increasing. And we can also observe the opposite. When f at x is decreasing, we'll notice that our derivative is negative. So we can say f prime at x is negative when the function is decreasing. So what does this tell us in terms of the slope of the tangent? Well, it says the slope of the tangent is going to be positive when it's increasing and negative when it's decreasing. So look at that. When it's increasing, you can draw any tangent on that increasing function, and it's going to be a positive tangent. When it's decreasing, any tangent is going to be a negative tangent. And then again, when it's increasing, any tangent is going to be a positive tangent. Right? Because remember, the derivative is the slope of the tangent. So you can say slope is positive. I'm going to do my little short form here, positive, when f at x is increasing. And slope is negative when f at x is decreasing. Then we'll continue. And the last question says, what's the behavior of the graph when f prime of the graph of the derivative when the function is increasing or decreasing? So I've drawn these vertical black lines here, and I'm drawing over them in gold here. So you can notice here that, yes, we've said this, you have a positive value for your derivative when your function is increasing, and then right when the function changes from increasing to decreasing, we get a value of 0. That's a horizontal. Later we'll find out it doesn't necessarily have to change, right? If you analyze, say, a cubic, you can still get a horizontal. But same thing here. And that's going to be a very helpful point later for us to graph. To know that you get a horizontal tangent, the derivative will be on the axis. It's a good way to be able to figure out where the x-intercepts are for the derivative function. Right? Okay, so let's try some example problems then. The first one says find the intervals of increase and decrease for the function. Alright, so here's what we're going to do. If we want to know where it's increasing and decreasing, we're going to want to first solve for the derivative and then see where it equals 0. Where are those horizontal tangents? So let's do that first. So f prime of x is going to equal, here we have 6x squared plus 6x minus 36. And we're going to solve for when that equals 0. So we're looking for those horizontal tangents. Because it's possible that you can have a change between increasing and decreasing between those horizontal tangents. That's where it will happen. Alright, so we can pull out a 6. So x squared plus x minus 6 equals 0. Okay, get rid of that 6 now, and we'll get x plus 3 and x minus 2 equals 0. So two possible solutions. We have x equals to negative 3 or x equals to 2. That's where we'll have our horizontal tangent. So now what we're going to do is create a little chart. So let me go over here. We're going to create a chart. And we're going to compare different intervals. So first, let's look at the interval where x is less than negative 3. So this one. X is less than negative 3. Then we'll look at when x is negative 3. And then we'll look at when x is between negative 3 and 2. And then we'll look at when it is 2, and lastly, when it's greater than 2. That'll be all parts of our function. And we are going to look for the value of f prime at x, because that will tell us whether or not our function f at x is going to be increasing or decreasing. So to do that, we just pick some sort of test value. Doesn't matter, pick something that's easy. So when I say easy, something that's less than negative 3, maybe don't pick negative pi. A good one might be x equals negative 4. So you can plug x as negative 4 into our derivative function. If you plug it into here, you'll get 36. So that's a positive value. So that tells us our function at that interval is increasing. Now we know at x equals negative 3. That's the value you have to pick. That's not an interval. That's an exact point. We know that's going to be 0 because that's what we solved for. And so we have a horizontal tangent. Finally, pick something between negative 3 and 2. An easy one would be 0. So we'll go 0. And if you plug in 0, you just get negative 36. So that's a decreasing function. X at 2, that was one of our solutions. So that's a horizontal tangent. And finally, if x is greater than 2, we can pick, for example, 3. And f prime at 3 will be 36, which is positive, so we get an increasing function. So these are the intervals of increasing and decreasing for the function. Increasing here when x is less than -3, and here when x is greater than 2, and it's decreasing here when x is between -3 and 2. Now the second example is going to take this one step further. It's going to say to graph this, or we're going to do a sketch of it by finding those intervals of increase and decrease. So let's first find the intervals. To do that, we're going to find the derivative, which equals 3x squared plus 6x. And we're going to set that equal to 0 and solve for those horizontal tangents. So we can pull out a 3x, and that would be all times x plus 2, which equals 0. So we have two solutions, x equals 0, or x equals -2. So let's create a chart. I'm not going to create one as big, because I don't think I need to write when x is 0 and x is -2. Because we know that's where we have a horizontal tangent. Alright, so let's look at f prime at x, or specifically its sign. And let's start by looking when x is less than -2. Now you don't actually have to solve for the exact value. All you really need to know is if the derivative is positive or negative. So if we take something less than -2, like -3, and we look up here, well, this 3x would become negative. Right? 'Cause 3 times -3 is a negative value. And this x plus 2 would also be negative, because -3 plus 2 is also a negative value. And then you have a negative multiplied by a negative. So you don't actually need the exact value. All you need to know is that it is going to be positive. And if it's positive, then our function f at x is going to be increasing. Alright, now let's look at the other interval. The other interval would be between those two values. So when x is greater than -2 and less than 0, you can pick -1 if you like. That would make this 3x negative, but this x plus 2 would be positive, and a negative times a positive is going to give you a negative value. So we know this is going to be negative, and therefore the function here is decreasing. Lastly, we would want something greater than 0, like 1, for example. If you have 1, this would be positive, and this would be positive, and a positive times a positive is positive. So here your function is increasing. And we know in between them, we have our horizontal tangents. So if we're going to graph that, let me graph it over here at the side here. Just going to do a little sketch. We're not going to find all the intercepts and things like that. But we know at the point -2, somewhere over here, we have a horizontal tangent. And you can sub in -2 into the original function, and you would actually get -2 and 2 right here. So we have a horizontal tangent there. And then at 0, and if you can see the function 0, 0, you get 0 and -2. So right here, we have a horizontal tangent. Now before here, it's increasing. So it's going to look something like this, an increasing function. Then between, it's decreasing. And then after after 0, it's increasing again. So we can do a fairly decent sketch just like that, knowing that here it's increasing, here it's decreasing, and here it's increasing. So the last question says, consider the following graph of f prime of x. So this is the derivative of a function, and it wants us to somehow graph the original function. So let me create some axes here. Now a couple things we know. We know that here and here, the derivative is 0. If the derivative is 0 at those points, then we're going to get a horizontal tangent at those points on our original function. So this is right before 0, so somewhere here. This is just one example. I can't possibly tell you what the exact y coordinate is. So this is just one possible example of what the graph would look like. And here, we could have something at that same x coordinate here. And the reason why I placed this one higher than this one is because look at the values of the derivative. Right here, the value is always positive, so we have an increasing function. So right there, we have an increasing function. Here it's negative, so we have a decreasing function, and here it's positive, so an increasing function. Where here we have our horizontal tangents. So we start increasing, then a horizontal tangent, decreasing, and a horizontal tangent, and increasing. So our original function, one example of what it could look like, would be that.